by welcoming you to the Technical Forum here at the Group Exhibit Hydrogen and Fuel Cells 2013. We invite you to have a seat, have a drink on the house. Come and enjoy with us the next presentation by ITM Power, dealing with the topic a review of hydrogen internal combustion vehicles by the Business Development Manager Steve Jones. Give him a big hand, please.
Thank you. Good morning. So I'm Steve Jones from ITM Power. I'm here to talk to you about hydrogen internal combustion engine vehicles. I'm going to talk a bit about the vehicles themselves, and then I'm going to talk a little bit about how do you refuel those vehicles. So firstly, I'll just go through the main powertrains that are involved. So on the far side of the screen there, you can see an internal combustion vehicle platform. So you have the fuel tank, balance of plant, internal combustion engine, straight to the transmission. So this is, you know, the vehicles that we know and love and use today. In the center is a hybrid vehicle, so it maintains a tank, internal combustion engine, and a generator to provide electricity, but it also is hybridized to a electric drivetrain. So it utilizes both plugging in from the grid and also the fuel in the tank via the ICE to make more electricity to drive the vehicle. And then the one closest to me is a fuel cell electric vehicle. So in this case, you've removed the requirement to plug the vehicle into the grid and charge the batteries, and you're essentially charging those batteries via an onboard fuel cell. So you have a tank that stores the hydrogen, you have a fuel cell stack with a small hybrid battery in there to provide the drive for the electric transmission. So this is where we all ultimately want to get to, is the fuel cell electric vehicles, and there's some stepping stones to get there, and I'll talk a bit more about that in a moment. So comparing the different types of drivetrain now with top speed, range and refueling time. You can see the different colored bars represent the sections. So internal combustion engines, they can achieve high top speeds, they've got long range and short refueling times. So looking at a snapshot of the emissions from different types of fuels. So you've got range along the bottom, and then you've got amount of CO2 emissions going up the vertical axis. And as you can see, obviously the vehicles that we use today, the gasoline and diesel vehicles, very high range, but also high emissions. So what we're talking about with hydrogen internal combustion is a mixture of the familiar technology that we all know surrounding internal combustion engine vehicles, but coupling that with a low emission fuel to drive that vehicle. So there was a review of Powertrains for Europe, looking at battery electric, plug-in hybrids and fuel cell electric vehicles. This document is available on the internet if you want to go into more detail. But essentially it was looking at defining the role of hydrogen in Europe for different types of vehicles. And the broad conclusions from the report state that for medium and long range transport, excuse me, fuel cell electric vehicles are the preferred choice. That's due to the the short range of battery electric vehicles. So that market can be up to 50% of the car market, and producing hydrogen and using it in fuel cell electric vehicles, you can achieve significant reductions in CO2 on a well-to-wheel basis. So the prerequisites for rollout of hydrogen vehicles, obviously rapid refueling, performance and maintenance are key. Disruption of our current refueling experience and the way that we operate, the way that we refuel our vehicles, the range, the time between refuelings, all of that needs to remain as close to our current infrastructure as possible. Obviously, early adoption for this technology requires government support and subsidy to get the technology out there in the marketplace and achieve the kind of volumes that are required to reduce the price. So cost reduction is critical, and where hydrogen internal combustion comes into it, in my view, is a stepping stone from where we are today to a full fuel cell electric vehicle fleet. There's a middle ground there. We need to get there, and internal combustion vehicles can provide a pathway to get us there. So hydrogen internal combustion vehicles, the fuel cell platforms are currently targeting personal transport, so the cars that you and I drive around in normally, passenger vehicles. Nobody at this point in time is really seriously looking at a commercial vehicle, so a van or a pickup truck or something like that, for wide adoption. And they are target markets for early adoption of hydrogen. The return to depot fleet vehicle, so a vehicle that returns to the same place each day to be refueled, is a perfect target market for early adoption of hydrogen, because you only require one hydrogen filling station at the depot. The vehicle leaves on its daily route but returns to that same point each day to be refueled again. And those vehicles primarily are not passenger vehicles, so they're vans, they're light commercial vehicles. So internal combustion can offer some benefits for low carbon vehicles. Light commercial vehicles require a high peak power output, which is easily achievable with an internal combustion engine. As I said before, many operate on this captive fleet idea, at which lower range can be acceptable, single point of refuel, but critically in this market, cost is almost everything. So these guys can't afford to spend hundreds of thousands of pounds on fuel cell versions of the technology if it was available, and internal combustion is a lower cost route to achieving zero carbon transport. And also things like service, maintenance, breakdown assists, all these kinds of things are already implemented for internal combustion engine vehicles. The infrastructure is there, ready to go. And a hydrogen variant of an internal combustion engine vehicle is very similar to the vehicles we drive around in today. So it's a stepping stone between where we are now and where we need to get to, which is a full fuel cell electric vehicle fleet. So an example of some internal combustion vehicles. So a couple of the OEMs have played around with internal combustion hydrogen in the past. So Mazda have done some vehicles, BMW have done some vehicles, but now really there is no active OEM that's looking seriously at internal combustion engine. They're all concentrating on fuel cells. The central picture there is a vehicle that ITM converted to run on hydrogen. So it's a very similar conversion to a LPG or a CNG conversion. It stores 4.5 kilograms of gas. It's 110 horsepower. It retains all of the load space of the normal van, so none of the space in the back of the van is taken up by the hydrogen system. It meets all the proposed Euro 5 and 6 emission standards. It's got a range of about 100 miles. That's limited by the amount of storage that you can get on board the vehicle. And you're talking, say, £36,000 to convert one of these vehicles versus hundreds of thousands of pounds for a fuel cell variant of the same vehicle. And also, another point about these vehicles is they're dual fuel, so they can be 100% hydrogen or they can be 100% gasoline. So they retain the gasoline tank and the drivetrain. So in terms of range anxiety or fuel provision not being there, you can simply just switch and drive the car as normal on your gasoline fuel. So I'm now going to talk a little bit about how do you refuel these vehicles, and specifically I'm going to talk about a unit that we've used to fuel the internal combustion engine vehicles that we developed, and it's a unit called Hayt Fuel. And Hayt Fuel is a mobile hydrogen refueling station. It was built by ITM. It consists of 2 shipping containers, as you can see in the bottom picture there. The first of the shipping containers houses electrolysis modules. So It's for on-site generation of hydrogen via PEM electrolyzers. The capacity of the unit is around 15 kilograms per day. The second of the two containers houses storage cylinders and a control system to dispense fuel to vehicles. So this picture here is the inside of the second of the two containers. And the unit is designed to be plug and play, so all it requires is a flat, level ground to site the unit. It requires a connection to power and water, and you can generate your own fuel at the point of use at the depot. And actually this unit is currently outside next to the ride and drive area, so if any of you guys get a chance to go outside, you can have a look at the unit. We're doing some live refueling demonstrations, so you can see exactly how the unit operates. So this unit was trialled on the UK's largest hydrogen vehicle demonstration program in 2010 and 2011. That program was called the HOST Trials, that stands for Hydrogen On-Site Trials. There were 21 commercial partners in the trial, and what the trial consisted of was our mobile refueling unit, 2 internal combustion engine hydrogen vehicles, and the unit would travel to the customer's site, be installed on their premises, plugged into water and power, enable them to generate hydrogen. They would then remove 2 of their existing vehicles from their normal everyday fleet, replace them with the hydrogen vehicles, and then trial it for a period of weeks to understand the technology and to literally kick the tires and test out the technology. So there were 21 commercial partners from a broad range of industrial sectors. So the partners on the trial are around the wheel that you can see, and they're a mixture of utility providers. There are some emergency service companies in there, local councils, delivery vehicles, construction companies. So a broad range of people tried the unit, and some of the snapshots of the trial, so 270 plus refueling events, over 10,000 kilometers traveled on hydrogen using over 50 different van drivers. During the trial, there was 100% availability of the hydrogen plant. The vehicles themselves didn't have any downtime. There was no problems about reliability, and the trial went very well. So, in summary, hydrogen internal combustion engine vehicles can provide a stopgap between where we are today and where we all want to get to ultimately, which is a full fuel cell electric vehicle solution. So, light commercial vehicles are currently not on the roadmap for fuel cell electric vehicle manufacturers, so they provide an ideal route for early adoption, really, because they all return to the same place to be refueled every evening. You can put down a refueler at that particular site that services a whole fleet of vehicles. In the markets that I've been talking about, reliability is key. So familiar technology is looked upon as a positive step with these guys. So they're all used to dealing with internal combustion vehicles. They have the service and maintenance programs already set up. So it's not a huge step change that we're talking about. The internal combustion engine vehicle is robust, it's reliable, and it operates very well, and it allows you to get to a zero tailpipe emission vehicle in a kind of halfway step between today and the fuel cell vehicles of the future. So, so that's the presentation. I'll be happy to answer any questions that you've got or any comments that you might have. Thank you.
Thank you, Steve, for this very interesting presentation.
Thank you very much. My name is Dapo Ogumoyiwa.
Hi.
My question is, do we really want to get to fuel cells as a long-term solution? Because for automotive applications, they do not have the mobility of the internal combustion engines. My question would be, if we could improve the efficiency of the internal combustion engines, wouldn't that be a better solution than a fuel cell?
I think it's a good point you make, and we've spent 100 plus years developing the internal combustion engine vehicle, and the infrastructure and everything is already in place. So it's a sensible place to start. I think that an internal combustion engine vehicle, as it currently stands, will always have an inherent lower efficiency than the fuel cell electric vehicles that are being developed. So yes, it will be cheaper. Yes, it will be a lot more similar to what we're doing today, but there will always be a lower efficiency, and therefore the miles per kilogram of hydrogen that you travel will always be lower. So particularly in passenger vehicles, packaging is critical. So the amount of hydrogen that you can get on board a vehicle is limited to between sort of 4 and 5 kilograms. So the efficiency of the vehicle is key. You need to travel as far as possible using those 4 or 5 kilograms. So the limitations with internal combustion is that you will always suffer that lower range than a fuel cell version. So.
Thank you.
Thank you very much. Does anybody? Yes.
Hi. Can you just tell us what's the cost if you look at the electricity used to generate the hydrogen and relate that to the distance travelled?
Sure. Yeah. That's a good question. I've actually got a couple of slides. If you come to the ITM booth, that I can share with you. But in short, the host trials that we did with those 21 commercial partners, the equipment was heavily data logged, and we gathered a lot of data, and we analysed it, and that was one of the the key things that we looked at. And in short, it depends how much you pay for your electricity, obviously. Again, the industrial companies that we were talking to and that were using this technology, a lot of them are heavy users of electricity, so they do pay relatively cheap wholesale price for their electricity. And trying to compare it on a pounds per gallon equivalent with a diesel vehicle, if you can pay around about between 5 to 7 pence per kilowatt hour for your electricity, it's comparable. So the price that you would pay for diesel to run your normal diesel fleet, you can run hydrogen for the same price. But it's, the price of electricity is critical for electrolysis.
Thank you very much. Are there any questions or remarks left here now? Okay. Where can I find you if I like to discuss in detail?
ITM's booth is B60. It's just at the back of the public forum over there. And also our refueling unit is behind me in the car park next to the ride and drive area if you wanted to go and have a look at the refueler.
Okay. And you are here the whole week at the group exhibit?
Yep.
Okay. Thank you, Steve.
Thank you.
So if you like him to discuss anything or to meet him, please don't hurry. Thank you very much. So after a short break, we will continue our program at 11:20 with the European Day, starting with some presentation, followed by a short discussion.